In the previous lecture, we implemented a large amount of user interaction functionality for our application. Now the users of our app are able to add, update, and remove items from the list of items that is maintained in memory. Technically speaking, we are maintaining two lists. One is part of the underlying names of the product held in the list widget, and the other is the more comprehensive vector of pointers to item objects, which contain not only the product names, but their quantity and image locations as well. While we could use other techniques, such as Qt's property binding, to associate the data and widgets, I've chosen to do some of this manually, so we have to write some of the algorithms ourselves to achieve our goals. But again, there isn't just one way to implement this application. If the task were given to a dozen different software engineers with different background, there would likely be 12 different implementations with varying degrees of similarity among them. Now, we come to the primary topic of this lecture: persisting our data. As we've seen, every time we open our application and close it, and then open it again, we have no way of restoring the data that was in our list and vector before. That's because all the data is in main memory, that is RAM, random access memory. In order to make the data persistent, we have to somehow write this data to a secondary storage device. In our case, we'll be using fairly straightforward file I/O that we learned about earlier in the course. We could, of course, send the data over a network to a database or even create a local database. But since file I/O is sufficient and effective for our current purposes and our incremental learning, I've chosen that for data persistence. Thus, we need to implement the Save Products and Load Products functionality that is under the File menu in our application. So let's modify our main window.h and main window.cpp files to add this new functionality. First, we'll work on the save functionality and see if we're getting a file created and that it contains the data we expect. Alright, so main window.h is over here. We're going to go in this right here and just add the two method prototypes that we need. Handle save items and handle load items. Good. And now if we go over to main window.cpp, I'm going to scroll all the way to the bottom here, and we're going to add the stubs for those two menus and then connect them, or stubs for those two methods and then connect them to the menus rather. Handle save items, and of course handle load items. Now let's go up here into the constructor and we'll perform our connections. So first we're going to connect menu save products to QAction triggered this main window handle save items. And secondly, we're going to connect menu load products to the QAction triggered handle load items. There we go for those. Now I'm going to notice some breakpoints we can remove. I'm going to scroll down and go to the handle save items, and we're going to do some implementing right here, and then we'll swing back around once we're sure that the save items is working, and we'll implement the handle load items. So the handle load items will remain just stubbed out right now. Doesn't have any implementation. So inside of handle save items, output file, we're going to have this file called products.txt. It'll get created if it doesn't exist. It's not sure what Q file is, so I'm going to click in here. I could just do include Q file at the top, but I'm going to do Alt-Enter on Windows, and then you'll see it has Q file. I just click it, and it'll, of course, automatically add it to the top right here. All right. output file.open. I'm opening it for writing only, and then you use bitwise OR and QIO device. It's writing text. At some point I need to create the text stream that will work with it, so we'll do that now. Stream out, output file. There we go on that. And at the very bottom, we're going to say out.flush and then also output file.close. And let's see here, QTextStream is not entered or not included, so we're going to do that. QTextStream. Make sure we've got that. Now the error seems to have gone away, so we're good on that. And now, once we've got this, we're going to output each product in a single row. Now it's really our decision how, in other words, what format. I mean, we could output it as JSON or XML or some custom format we come up with. We're going to kind of go the custom format route, but we're going to use like a comma separated list. So we could have made that products.csv or even a custom file type. We could say .john or .storeinventory or .si or whatever we want, really. At the end of the day, there's really only two types of files. There are text files and then there are binary files. We're deciding to output each product in a single row with its name, quantity, and image path separated by commas. We will explore how to split the strings by commas later when we read the data into memory, we load it, and implement the load functionality. But for right now, we could use a regular for loop, but I'm going to use the range-based or enhanced for loop. This is a newer feature in C++, but it's not crazy new right now. It's probably about I think this one's probably a decade old or so. Relatively speaking, though, C++ is a pretty old language. So notice I did not do endl. I'm just separating this so it looks a little prettier in the code. We're doing get quantity, writing that out, another comma. Notice I'm not putting a space after the comma. I'm just putting the comma in double quotes. And again, get image file path. And then I put the endl because that's the last piece of data. So it's basically going to have the name, comma, quantity, comma, and then file path. The file path has none.png in it automatically if you don't do anything. So that's what we did originally when we implemented these. So let's run this. I'm going to run this. Built it. I'm going to go to build run. And we're going to do a little bit of manipulation here. New product, we'll say fudge. And we'll do 10 of those, right? And we'll do maybe bread, 2 loaves of bread. There we go, confirm add. So we got my bread and my fudge here. Maybe an apple. We'll just do 1 apple and confirm add, right? And then maybe I'll add one that I'll test. I'll say eggplant just to test it, make sure that I can remove it. Good. Got apple and bread and fudge still. I'm going to go to save products. And then I'm going to see if it actually wrote the file. So you'll notice I've navigated into the build directory of the project, and there's a products.txt. If I open it, I do in fact have pretty much what I expect, right? Fudge 10, none, bread 2, and then images / bread, apple 1, / images / apple. So pretty cool. It seems like we're writing the data correctly, and we chose this format. We could have easily chosen a different format. We could have done XML writing again. We could have done JSON. We could have had a separate library that helps us write those formats. There's all kinds of things we could have chosen. standardized formats. This is fairly standardized because it's using a comma-separated list, or .csv file would normally be the file type. And if you open that in Excel, this would actually appear in columns. So it's actually pretty cool. Interoperability built in already. But again, that's just basically the file that we've written out. We want to make sure that we can open it as well. So we have our data written to file, but we have to have a way to retrieve it and parse it effectively. So we have to make sense of that data in the file. Otherwise, it's just a text file. It makes no difference to our application whether it's that or some novel or Hamlet or anything else, unless the application understands how to use it, what to do with the data that it loads into memory. So here's what we're going to do. We're going to read the data line by line into a queue string, and then we will use the handy little split function on the queue string to split the full line into 3 components: name, quantity, and image path, based on the comma separating them. We can tell split, hey, these things are separated by commas. I want you to split it into basically an array. And the return value of the split function is something called a queue string list, which is a data structure specifically for holding queue strings in a list. So every time we split the line, we will have 3 elements at indices 0, 1, and 2 in the queue string list. That will be the name, quantity, and image path, respectively. Awesome, let's get to it. So the main window.h file doesn't change for us since we created the method prototype already. We just have to fill in the code for handle load items in main window.cpp. So I'm going to go back to here, and we originally stubbed this out, and now we're actually going to fill it in. So queue file, input file this time, and we named it products.txt. And we want to open the input file, so input file.open QIO device, and we'll say read only, and then QIO device for text. And then at the very bottom, we probably want to, I guess we'll wait until we create the text stream, and then we'll do that. So Q text stream in, and then input file, base it on input file. Now, at the bottom, what we want to do is we want to make sure that the input stream is flushed. It's probably going to be fine by this point, but just as a precaution. And then we close the file so we don't have an access handle on it. So we're going to clear the current list and vector and then read the new ones into memory. So this is one thing a lot of people might forget when they first do load functionality. Then you'll end up with duplicates of things in your list possibly. So we need to clear the current list and vector. Okay, so for item pointer temp in the product list, you're going to just call delete temp. So that will delete the memory for those. Product list is going to get cleared, so that's my vector, and then UI list products. That's the UI component. So this one is part of our data model, the top one, and then this is part of our view or our UI, right? So if you ever hear of MVC, model view controller, these would be like the model and the view. The view is what the user sees, the model is the data that's being held, and then the controller kind of bridges the two. So now what are we going to do? We have a nice clean vector and we have a nice clean UI. So we're going to say while, just like we learned earlier in the course, while we're not at the end, what do we want to do? As we said, we would grab the line using n.readLine. So far, so good. And then use that handy split method, right? So QString list, I want to make sure that we have that at the top just so we're positive. We're going to explicitly say, hey, we're using this. QString, and actually I'm going to do QString list. Truth be told, some of these live in other files, so we get them indirectly, but it's always good to explicitly state what you're adding. So we've split it, and now we have the data at each individual component. So what we're going to do is first handle list of products in the UI. We're going to say UI LST products, add item, and we just need the text for the name. So info at 0. There we go. So that's the index 0. And now we're going to handle the vector, right? Item pointer product equals new item. And here's how it works. So we've got info.at0, there's the name. Now the second thing that we need is quantity, but it's an integer. What we read into file is text, so we need to convert that text back to an integer. Info.at1 dot to int. Since it returns a QString, we now have access to this toInt member function or method. And then info at 2. That gives us the image file path. Product list dot push back that product. So far so good. And of course, let's run it. So build and run it. Build. And run. And we're going to add some items, save it, close the app, and then reload it. File new product. Let's do fudge. We'll say there's 14 blocks of fudge. I'm going to say apple, 11 apples. I guess we have to counteract the fudge, right? Now we're going to do bread. We'll say I have 7 bread. And maybe, oops, I removed the fudge. That's sad. Okay, what about, let's see what else. What else might we add? You know what? Let's see what images we have available. And then maybe we'll add those. Bread, hamburger, hot dog. Let's do hot dog. We haven't done hot dog yet. Hot dog. There we go. We got to have at least 5 hot dogs. We will confirm add. Hot dog, apple, bread, and hot dog. Right? So 5, 7, and 11. Or, sorry, 11, 7, and 5. And let's go to File, Save Products. And now we're going to close the application. And I'm going to relaunch it. And it is empty, because we're not automatically loading. We don't want the user to have to do that, but we're going to do file load products. And there you go, apple, bread, hot dog. Let's make sure it works. Apple has 11, bread has 7, and hot dog has 5 with the correct image. Amazing. So we have a pretty nice little app now, and all the requested functionality is implemented. However, to really make this a lot shinier and a lot nicer, there are a couple little bugs that need to be taken care of. So I have a challenge for you. The bugs are, before the program closes, we don't free up the memory for the objects pointed to by the pointers in the vector. I'd like you to do this. A good place for this is probably the destructor, that is the method with the tilde in front of the class name. Since this is automatically called when main window object will be destroyed, this is a perfect place for this. And you may have noticed that when you remove an item, its image still remains. Even if all the products are removed from the list, I'd like you to fix that too. So, pause the video and come back when you're done, or if you need some help. How'd that go for you? Were you able to fix these little bugs? Let's fix them together. So, just to quickly show you, in case you weren't sure what I was talking about, you could repause the video if you need to, but I think it was probably obvious if you remove one of these, like if I'm on bread and I remove it, you'll notice bread's no longer in the list, but I still see the bread image. So that's a no-no. And the other one's a little harder to see, but that's what we're going to fix first, is the memory leak. So in the destructor, before or after we delete the UI, we're going to free up the product list memory. So free up product list memory for item pointer product in the product list. We're going to delete product. And you could, just to be extra cautious, You could do product list clear, but the vector takes care of its own memory, so it's not really that big of a deal in this particular case since the program is shutting down right now. But second, we need to fix the remove issue so that the image isn't shown anymore when the element is removed. So this will occur in remove selected product. So if I go down here, where is it? There it is. Remove selected product. So we're doing pretty much all we need, but the issue is that we want to set image to none.png, which is the default we've chosen. It doesn't really exist in our project. We could move a file in there called none.png. That's fine too. None.png and label image. We're going to set the pixmap to pixmap. And of course, we're going to run this again. So build and run. So build. And of course, once that's done, we run. And we will add a couple items here. So we'll say fudge. And oh, no image for that. So we'll confirm add on that. We will do new product apple and load the apple image. And we'll add hot dog. So we'll say dozen hot dogs. Don't eat them all at once. You might die. All right. And then we have, of course, let's do hamburger. So we'll do, again, dozen hamburgers. Don't eat those in one sitting. All right. Hamburger. There we go. So hot dog, for example, if I hit remove, the image is now gone. Very cool. Before it was just sitting there. Now, if I click on hamburger, it will now show the hamburger, right? Pretty cool. Of course, you may have just chosen to set the text of the image label to an empty string or some other solution, and that's fine too. You don't have to do everything exactly the way I did. Another interesting thing you could do to make this even better is drop in the none.png image representing nothing. Maybe a question mark symbol or something like that. I did include one in the images you can download if you'd prefer or try to do that. So there are so many things you can do that are creative when you're dealing with GUI development. In the next lecture, we're going to finish off this section and the course. I'll see you there.